graph shown in the figure represents velocity time curve for an object. The corresponding displacement time curve is best represented by. So here what you can see is the gradient here. You can see this is a positive velocity reduces and comes to zero. Then again negative velocity increases. And when you take a look at this, you can see that it has a constant gradient, a constant slope, a constant gradient. And you know how to get the gradient? Gradient is the angle, the tan value of the angle between the positive direction of the x-axis and the tangent drawn to the graph at a certain point. So you can see that the angle made with the x-axis and the tangent drawn to the graph in this question, which is the graph, to be exact, it's constant, right? It's a constant angle, and you know it's an obtuse angle. So this tan theta value is a minus value. So it's a negative gradient. So what we have here is a negative constant gradient, right? A negative constant gradient. A negative constant gradient. And you know, gradient of a velocity time graph gives us the acceleration, right? So it's a negative constant acceleration. So what we have here is a negative constant acceleration, a negative constant acceleration. But the problem is what we are supposed to draw is not the acceleration time graph, but the displacement time graph. So let's try to draw the displacement time graph, and also we need to know about the displacement time graphs. So how do you represent velocity in a displacement time graph? That is the problem. How do you represent velocity in a displacement time graph, right? So let's see how to represent displacement velocity in a displacement time graph. So in displacement time graph, the gradient will give us the velocity, right? So what you can see here is that it starts with a positive velocity and reduces to zero, and negative velocity increases afterwards. So positive velocity reduces to zero, and then the negative velocity increases. So the positive gradient should be decreasing to zero, and then should negatively increase. So let me write that here. I'm going to write that part because the gradient of this graph doesn't relate much to the question. So the observation from the graph is that positive velocity reduces to zero and negative velocity increases from zero. So similarly we can say gradient of the ST graph, you know, the gradient of the ST graph is velocity. So you can say gradient of the ST graph is positive and reduces to zero. Then the negative gradient increases from zero. The negative gradient increases from zero, right? Then the negative gradient increases from zero. So let's draw it. Positive gradient positive gradient here reduces and becomes 0. So you know, gradient becomes 0 when when the graph is completely horizontal. Here the graph is completely horizontal. So initially have a positive gradient, that means a positive angle, and becomes 0. Then gradient becomes negative, so it's an obtuse angle, and it's increasing. You know, gradient value is increasing when the curvature increases. So the answer is the second one.